Hi, I'm NitroJen and welcome to our session on magnets and magnetism. So we are going to do a couple of demonstrations for you today using some of the equipment that we have here, and there's a couple of experiments that you can follow along with at home too. So there's a couple of items that you might want to fetch. So I'll give you that list of items and then you can pause me and then we'll carry on with our activities for the session. So you're going to need some sticky tape, a little bowl to put a bit of water in, a pair of scissors, and that's to cut out some little fish, so some little paper fish. You can print off a template, we'll put a link in at the bottom, or you can design your own and draw them. Going to need a pencil, a ruler, a little bit of string, and this is about double the length of the ruler, so about that length would be great. Going to need a cork, so it's just a simple bit of cork. You might need to ask an adult to cut it in half for you, so we need to have a flat edge to our cork. Going to need some metal objects. So here we've got a few paper clips, we've got a ring pull from a can, and we've got a nail or a pin would be fine, but just be careful of the sharp end. And then most importantly, we're going to need a magnet. So it can be a bar magnet like this one, or it could be a magnet like you'd stick on the fridge to hold some notes. So it could be a little magnet like that. Or if you've got any toys with magnets in, these sort of geomagnets, Magnetex toys would work as well. So these little magnets would be fine. So if you want to go and fetch those now, press pause and then we'll begin. So now you've got all your equipment, let's have a look at the magnets. Magnets are really interesting. So we know that we can put magnets on the fridge and they stay on there. Sometimes they can stick up little notes and hold different things to the fridge door. And we know that they have this weird force that we can feel. We can feel it pushing and we can feel it pulling. So when we put opposite ends together, it seems to attract and pull towards one another. And when we put the same end together, we find that they're moving away, they're forcing each other apart, and we're pushing and repelling. So this is really interesting. And what that tells us about the magnet is there are two distinct ends to it. And you'll notice that these particular magnets are coloured. So they have a blue end and a red end. One end is South Pole and one end is the North Pole. So those are the words and terminology that we use to describe a magnetic field. Whilst it's invisible, there is a way that we could reveal this magnetic field and have a look at it a bit further. So I have here a magnetic field viewer. So this is a little container that has lots of little magnetic particles inside, and they're suspended in a liquid. So they're sort of freely floating around in there, all those little black dots that we can see. What we can do is we can put a magnet like this one behind the field, and all of a sudden we start to see a shape forming at either end of the magnets. So we can see where all the little magnetic particles are being pulled in towards either ends. So this allows us to see the magnetic field. So that force that was really visible, pushing things away or pulling things together, we can actually start to see where they're attracting and pulling them towards each other. So that's really interesting. Now we can actually see how far this force can pull or attract using a ruler. So one thing that we can do is take a ruler, put a magnet at one end of the ruler. So if you set it towards the zero end of the ruler, and then you could take something magnetic, like another magnet, or a paper clip. You can see how close you have to push that item. So in this case, I'm pushing towards the paperclip before it jumps. So I managed to get that to jump about 3 centimeters. That's pretty good. So it's a fairly strong magnet. It's one way that we could test, see how strong a magnet is. If we were to put another magnet there as well, we could see how far we could push it for it to push the other magnet and repel it away. So these are both quite strong magnets, and I'm pushing them, it's about 2 centimeters there before it got pushed so far away. So this is really interesting. We're playing around with forces. So what these magnets are made of are a type of metal, and the majority of magnets that we come across that are naturally found have a certain amount of iron inside. So this iron ore is actually a metal that we used to extract and use to create all sorts of things and take advantage of that magnetic field. And it was discovered a long time ago and then utilised to create a compass. So a compass like this one here actually is a little bit of a magnet. So this little needle here is basically a really small, lightweight magnet. So a bit of metal that's got a magnetic field inside. And it's pointing towards north. So wherever I put it, provided there's not too many other magnets around, which there are at the moment, it's going to point towards north. And that's because our whole planet, planet Earth, is in fact a giant magnet. Planet Earth has a giant magnetic field. Inside of our planet, we've got some molten iron ore, and that acts like a huge magnet. So it has a north pole and a south pole. So where we've got magnetic north and magnetic south, we also have a geographical north and a geographical south. But the magnetic north and south pole can actually change over millions of years. So it moves around a little bit, whereas we know the north pole and the south pole physically stay still, the geographical north and south. But you can imagine that there's a little magnet inside. Now, if there's a little magnet inside of our planet, then our compass needle is going to be pointing towards it. So our compass will turn around and that will point towards the North Pole. So this is how we would navigate around our planet. Now, what's interesting is some animals have a very small amount of magnetic material actually inside of them, and that helps them to navigate their way around too. So pigeons, homing pigeons, are renowned for being able to track their way back home, and they have this little element inside that enables them to find the magnetic north or south pole. So whales and dolphins supposedly have the same thing too, which I think is quite interesting. So what is it then that makes something magnetic? Well, we'd have to look at something on a very small scale. So all of our objects in front of us are made of lots of different materials, and if we were to look at them with a huge amount of magnification to make it look bigger, we would notice that they were made of molecules, and each of those molecules are made of atoms. I've got a little sort of model of an atom here. So this is kind of representing what an atom might look like. We have a nucleus right at the beginning, and then we have some little bits that spin around. So these little black dots are meant to be those bits that spin around. We call them electrons. And these electrons normally spin around in a chaotic manner inside of something like a piece of metal. But the difference between one metal and another is whether or not all of the electrons are spinning in the same direction or whether they're all spinning randomly. And this is what the difference between something that's not magnetic and something that is magnetic. So, a little picture here that will help explain. So something that's not magnetic, all of these electrons are spinning randomly and they're all kind of chaotic. Something that is magnetic, the electrons spin in the same way. And this creates the poles, the North Pole and the South Pole, the magnetic North Pole, the magnetic South Pole, not only on our planet, but also in our magnets. You might see it looking a little bit like this too. So it's a nice example of them all sort of being in a different direction, whereas they're all floating one way or the other. That's what creates this invisible force that we can see. So let's have a look at what cool things we can do with it, and we can have a go at making our very own compass. So for this experiment, we're going to need a bowl. We're going to need a little bit of water. So I've got a little jug of water here. We're going to need our cork, and we're going to need a needle or a nail. What we're going to do is create a floating magnet. And I've got a really good example one here. So this is a magnet. We've got a north and a south pole. We're going to add it into a little bowl of water here. And this is a specially designed bowl of water because it's got all the letters pointed out, north, south, east and west. And it does float. So if we pop it on top, we can get our magnet to float. And naturally that will find the North Pole and point towards north. But what's interesting is we can create our own version of this. So if we take our bowl and pour water inside, so we just want a reasonable amount so that we can get our cork to float. And what we're going to do is we're going to put the nail or the pin, if you've got a pin, on top. We want to pop it on top and make it float. But our nail at the moment isn't magnetic. So if I try to get it to pick up the paperclip here, it's not going to pick it up. Whereas our magnet will attract both of them. So what we're going to do is we're going to make our pin or our nail magnetic. And to do that, we are going to need to use this magnet and rub them together. So do be careful because it's quite spiky on one end of your nail or magnet. And what we want to do is we want to rub the nail down the edge, or the pin down the edge of the magnet. And this will transfer and create the same effect that we've just looked at. So we'll get all those little electrons lining up in the same way. Now it's always important to make sure that we're rubbing the nail down in a straight line so that the flow of electrons continues to be straight. If we do it backwards and forwards or in different directions, then we're going to create some chaos with those electrons. Be really careful as you do so, and then we will have given it a magnetic property. We can see this one's really affected by the magnet. Look, ooh, look at that floating around. Pretty cool. So we're going to pop that now on top of the cork, and we want to just put a little bit of tape on to hold it in place. There we go. So pop a little bit of tape on. So we've got our nail just resting on that little bit of cork. We're going to float it on the water. Put a little bit more water on just to bring that surface level up so you can see it a bit better. There we go. There we go. And this nail will now have a north and a south pole, just like our magnet will. And it will naturally want to find north. So I'm just going to pull this magnet away so they're not influencing each other. And it will settle down when the water's not being disturbed and point towards the north pole. There we go, starting to point in the same direction as this one now. As soon as you put a magnet near it, then you'll notice it kind of wants to follow it. So again, we're able to make it spin around, which I think is quite a cool effect. So let's have a look at what else we can do with magnets. Now, I quite like the idea of making things a bit magical, making things move along and making it look like an invisible force. So we've got some special cards here. And we've got a couple of discs which are magnetic. Again, we've got a north and a south side to these magnetic discs. And if we put the opposites together, they're going to attract one another, pulling each other together. And that enables us to be able to drag one from the other. So we have to use a bit of effort to pull them apart, and then we can get them to follow one another and they're attracted. But if we turn them around, have a guess what you think might happen? Oh, look at that, fairly quickly. They're going to repel one another and push each other away. It's a little bit like an invisible force that's affecting these cars right now. Now, if we look at these little magnets, we'll notice that they've got a hole inside, and there's a reason for that. We can put them on a stand. And again, if they're facing the opposite sides, they're going to stick together like this. But if we put them on the stand through the hole, make them face the same way, we can get them to repel. And then they start hovering. So we've got south to south, north to north, south to south. And we get this really cool effect. It almost looks like they're levitating, they're hovering on their own. And there's quite a lot of force there, so you can have a feel of how harsh that is to push down. You have to put quite a lot of force down. And they'll spring back up. So this is really interesting, how this invisible force can have a big effect on the world around us. So magnets, as we said, are found in lots of metals that have iron inside. There are lots of different magnetic materials, and they can all come in different shapes and sizes. So sometimes we find it naturally occurring in hematite, so quite often it gets used in types of beads for jewellery. And sometimes they come in little iron filings. So these are little iron filings, they're tiny little shards of iron, and that's the dark bits, and then all the yellow bits here are some sand. So this is a iron filing and sand box. What's interesting is we can use a nice strong magnet to separate the two layers. You can see every time the magnet gets closer, it's pulling up and attracting all the iron filings and separating the two together. So we get this really cool effect. And again, we can see that there is a definite magnetic field on the ends at the poles of our magnet. It's pretty cool. Let's have a look what else we can do with our magnets. So we take a magnet and our paper clips. We've got 4 little paper clips here, and our paper clips aren't magnetic on their own, so I can't use one paper clip to pick up or attract the other paper clip. But if I put the magnet near it, then we can see they will jump towards the magnet. So there's a metal that's in there that's attracted to the magnet, but it's not strong enough or known to create a magnetic field. So what we can do is create a temporary magnetic field. And we can do that just like we did with the nail or the pin that you use to make your floating compass. So we can take the paper clip, we can run it down the edge of the magnet. So again, in the same direction, whoops, so in the same direction, so that we are lining those electrons up to make a north and a south pole. And then we can add it to the end of the magnet, and we can do the same to the next paper clip and see if the magnetic field extends through one to the other. Now I reckon I could make all 3 paper clips stick on. Oh yes, can we get the 4th? No. Oh, they've fallen off. But you can have a go at this. So we're creating a temporary magnetic field. So it's travelling through the paper clips there and sticking to one another. So that's quite interesting. Now, if we were to do the opposite then and make things push away, we can create a temporary magnetic field that repels. So I've got this little contraption here. So this is a little bit of plastic. It's got a little channel going all the way through. I've got some slightly stronger magnets. So these little magnets here are called neodymium magnets, and they're very strong. We want to keep them away from anything else that might be magnetic, because they can affect the magnetic field. And in fact, magnets get used in lots of digital things, so our phones, our computers, iPad screens, lots of things like that. We want to keep these magnets away from it. And then I've got some ball bearings which are not magnetic. But again, they are made with enough metal in that has the capability of being attracted to a magnet, but themselves are not magnetic. So we can use that to create a temporary magnetic field. So I'm going to put my neodymium magnets here, put 2 of the ball bearings next to it. What we're going to do is we're going to drop one ball bearing and get it to hit the neodymium magnets and see what happens. Whoa, come back. As you can see, there's quite a powerful reaction there. It's repelling with such force that even though we put a little bit of energy at the start, lots more energy comes out at the end. So we'll try it again. And we'll try it this way round, just so you can see how fast it is. So when scientists were investigating magnetism and different properties of magnets, they found out that you can use an electrical current to make a really strong magnet. So we have a special contraption here. So we've got a horseshoe-shaped bar of iron. We've got some copper wiring that's twirling around both ends of this magnet, and it's actually connected between the two. And we've got another piece of metal at the other end. And we'll notice that actually there's no magnetic properties here at all. If I try and get them to stick, they're not sticking. But this changes when we add a battery. We add a current, a little bit of electricity. So our battery here has stored energy inside, and the chemical reactions that happen inside of these cells produce electricity. So we're going to take some crocodile clips and connect the battery to copper wires. So we've got a copper wire at this end and a copper wire at this end. And at the ends of the crocodile clips, we're going to connect to the battery. So I'm going to pop this one at this end and this one at this end. And when we connect it, we're going to notice, let's see, oh, there it goes. We've created a magnetic field. And if I try and hold that up now, we can see that this bar has now got stuck to the end. It's been attracted and it's really quite hard to pull apart. Whew. But whilst the current's running round, this electrical field is making a magnetic field, and it will stick back on. As soon as we disconnect the battery, the magnetic field is weakened and we can pull them apart again. Now, we use this technology in scrap yards. So if you've ever seen a nice big machine picking up cars to take it to a compactor, then it's using this technology, and it's called an electromagnet. So the machine has a really large magnet on the end that it becomes magnetic when an electrical field gets pushed through it. So it needs a lot of energy from electricity to pass through the wiring and create that magnetic effect. Now, I think we should have a go at making a little fishing game. So for this, we're going to need your paper fish. If you'd like to cut them out and colour them in. So we've got some nice little fish. We're going to need to take the pencil and your little piece of string, and we're going to tie one end of the pencil onto the string, so just like this. So it doesn't matter whichever end you find comfortable. And then we can take your little magnet, so whether that's a fridge magnet or a bar magnet like this one here. So I'm going to take a little magnet like this one. I'm going to tie it to one end of the string. So one end we've got the pencil, and the other end we've got our magnet. This is going to make our fishing rod. Like this. There we go. Now our little fish, once we've coloured them in and decorated them, on the back we want to stick an object that we think might be magnetic. So a paper clip or the ring pull from earlier. And just tape it onto the back. So this one's got a paper clip. This fish has got the ring pull. This one's got a paper clip. You can see what else little objects that we can find might be magnetic. A staple might be as well. We could also test things that aren't magnetic. Now, if we turn the fish over, we're hiding those different materials. We can have a go at which fish we can catch with our magnetic fishing rod. Oh, that's interesting. I couldn't catch the yellow fish. And that's because of the material that our ring pull is made from. So these cans are made from aluminium, and this ring pull is aluminium, and there isn't any magnetic properties in that aluminium, so our fish cannot be caught. So you can have a go at decorating your fish, and you can make as many fish as you like, with lots of different objects stuck on the back. You could try things that aren't magnetic, something like wood. You could try other objects that are magnetic, like our paper clips. Or other things around the house. If you decorate your fish the same colours, it'll make it really tricky to know which ones are hiding which materials and what might be magnetic. Now, if you wanted to try this fishing game out on your family, then you could create a little pond, and you can pop your fish into the pond. You can see if you can make more than one fishing rod and go fishing for your fish. See how many fish you can catch.